Hello and welcome. We just want to say thank you for working your way through this 3-week course. All your contributions, it's been really interesting reading questions people have put, comments and ideas that people have put as they've been going along.
There's been a couple of good questions that have come out at the end that we've done some video work for that we're going to show you. One of them is around how you use a multimeter, and we will have a look at voltage, current and resistance with that, and the best way of taking readings and some kind of problems that you might find, things like fuses that have blown. So we'll cover that. Okay, so at the moment what we're showing here is how to set up the multimeter if you're taking a reading for the current. So we've got two bulbs in the circuit and obviously the battery supply, and this is set up in series, so you can see the electricity is obviously flowing through the ammeter and back out the other side. I've got it set on the 10 amp setting for this, which means you have to use the 10 amp port on the multimeter. The reason for that with this one is because if you're using bulbs, you might end up with a reasonably high current. If it's anything over 200 milliamps, which is 0.2 amps, then you might blow the fuse. You can see there's another port on here which says milliamps on it, and in fact with this multimeter that has happened. And what you will find, if that is the case, so I'll put it on a milliamp setting, but you can see that the bulbs have gone off, and I'm not getting any reading on here, so there's not a pathway for the current anymore because the fuse has gone. So you need to replace that 200 milliamp fuse. So if you're using components such as resistors, diodes, LEDs, that kind of thing, you're going to generally be looking at milliamp kind of levels of current, and that means you have to use that setting, so you'll need to replace the fuse in there. Okay, so we're now looking at measuring the voltage across a component in the circuit. So obviously in this case you have to have the two wires going from either side of the component rather than the electricity kind of flowing through the circuit in series, so we're connecting in parallel. We're changing the setting to, in this case, the 20 volt setting. That's the maximum that you can measure on that setting, and we're measuring 2.6 volts across there. So you do have to make sure that you have it in the correct, you always have one wire coming out of the common port here, but for the voltage we use this one that has V ohms hertz on it. There may be cases where you want to measure the resistance of a component, so you can see the dial up here has an ohm setting for measure resistances. So we're just measuring the resistance of a bulb at the moment, so that's 2.7 ohms in this case. So obviously you don't need any power supply, any external supply in the circuit. In fact, this is acting as a very small power supply just from the battery inside that enables it to measure the resistance. Again, you want to choose the correct setting. If I put it onto 200 kilo ohms, for example, it's showing 0 because it's very low resistance component. There might be other things that you're looking at that are higher resistance where you need to alter the setting on there. So we had a question within the course about running the difference between an LED in a DC circuit, which is the one you'd normally set up. So something like this, where you've got a battery and an LED, and the current is only flowing in one way. But obviously you can get LED bulbs that you use in your house, and they are working differently. They're running on alternating current. So how does that work if the current can only run one way through an LED? So with this situation, the current is always flowing in this direction. If we swap that for an alternating current supply, like you would have in your house, then it's going to run okay one way, but as it tries to go through the other way, it's not going to be able to pass through the LED. So we can do something so that we don't lose half of the kind of energy that we've got there. We can do something within the circuit to try and what's called rectify the current going through. So if you imagine with an AC supply with time, you've got this happening. So this is going, one way through the circuit, this is going the other way through the circuit. We can put a rectifying circuit in so that actually it looks more like that, approximately. So you can see now with a bit of circuitry in here, it will always be flowing the same way through the LED. The other thing that we can do, and I think this is the case with some LED bulbs in houses, maybe not all, is that we can put a smoothing circuit in there using a capacitor and a resistor, so that actually I might draw it on this one up here. What happens is something like this. So at least you're getting a kind of more steady supply of current there. In fact, you could even put another diode in there to smooth that out, so it kind of cuts it off at that point there, and so you end up with a steady kind of back to DC again. So essentially what you've got inside the bulb is an AC to DC converter, and that can be done in different ways, but you end up with the result of the LED bulb being able to function. So we might assume that the LED bulbs that we use in our house are exactly the same setup as we might do for a simple LED in the classroom. They're a little more complicated than that. There's extra electronics that go in there, so it enables the whole circuit to function with an alternating supply as you get in the household.
And leading on from that, we've been asked when would be the correct time to sort of teach this difference. In an ideal world, you probably wouldn't, because it'd make life simple if you're just saying that current can only flow one way through a diode, and it's something that you're drilling home with your students. But obviously high ability students will want to know how this does work. So I would advise that you teach that after you've taught that diodes only allow current to flow one way through a circuit, and then possibly draw out a rectifying circuit which demonstrates how current can flow one way through it, and then the other way as the current switches direction in an AC circuit. The ages this would potentially be taught at are from ages from about 14 to 19, so those that are doing sort of the higher level electronics and electricity.
So there was a question about how can you draw together worksheets and videos and that kind of thing into one area to work with and share. So we do have a function within the STEM Learning website where you can create your own sort of resource lists, and you can share them across the site. So you can either link to things that we have within the site itself, or you can even do external links out, and we'll post some instructions about how you can do this.
And one of the things I found that was very effective when I was working in departments as a regular teacher and then as head of department was utilising our departmental meetings and setting aside 20 minutes, half an hour of those, where we'd say in the previous one, right, we're going to look at electricity at Key Stage 3. People went off, they looked at resources, they brought those resources to the next meeting. We sat down and the specialists gave an idea of this is the best sequence in which to teach it, and we placed the resources that people had brought into a nice teaching sequence that allowed progression and showed development of students' learning. Thank you again for engaging with the course, and we'd just like to remind you that not only have we got these amazing online courses available, but you can also come to the National STEM Learning Centre and meet us face to face, where we've got courses like Inspiring A-Level Physics. There's biology and chemistry courses here, computing, lots of bursary funded courses. So please have a look on our website and see how we can potentially help you.